Hello and welcome to GeoMind. I hope all of you are doing amazing. In this video, we are going to discuss about HM symbols. Since HM symbol is a little bit complex topic and most of the students have little bit difficulty understanding this topic, I'm going to make two parts. Okay, so this is the first part and soon we will upload part second of this video. Okay, so in this part we will be focusing on symmetry elements. Okay, now symmetry element is a very important topic if you need to understand the HM symbols. So that's why we will be focusing on symmetry elements. Okay, so as you can see, it is written here, HM symbols are basically the symbolic representation of the symmetry elements. So we need to understand symmetry element first, and then we will be focusing on that how we write HM symbols. Okay, for example, here you can see an example of an HM symbol: 4 cube, 4 by m, 3 bar, 2 by m. Okay, so this is a symbol which represent a cube. Okay, how we write this symbol and what does this represent? 4 represent, what does m represent, what does 3 bar represent? We will be discussing all of this. Okay, now as you know, HM symbol is a part of your crystallography section. It means that we are dealing with the crystals, right? And you know that crystallography also comes under your mineralogy. And in mineralogy, we deals with the minerals. We deal with the minerals. And you know that if you remember the definition of a mineral, you know that a mineral has to be a crystal first. If I am calling a substance mineral, it means that it should be a crystal. And what is a crystal? A crystal is an ordered arrangement of atoms, right? A crystal is what? An ordered arrangement of atoms. Now, if something is orderly arranged, it means that it should have some sort of symmetry, right? Or similarity in its shape. And from there only we get the symmetry elements. Okay, so let's start with the video. This is just a briefing about HM symbols. So my name is Swapnil, and if you want to join my Telegram group, I have given the link in the description below. And if you are new to the channel, don't forget to like, share and subscribe to GeoMind. Okay, so HM symbol, the name itself comes from two mineralogists and crystallographers. The German crystallographer was Carl Hermann, which basically proposed this notation. Okay, so the name Hermann itself comes from this scientist, and the Charles Victor Magen, which modified the notation in 1931. The Magen name comes from this scientist. Okay, all right. So you know that all the minerals comes under your 7 crystal systems, right? Isometric, tetragonal, orthorhombic, monoclinic, triclinic, hexagonal, and trigonal. And the trigonal comes under your hexagonal crystal system. Okay, for example, the cube itself, okay, we saw comes under your isometric system. And these crystal systems also have their subsequent classes also, right? For example, in isometric classes, there are 5 classes, okay, which we will look at. Okay, now this is just for your briefing. You need not to know that what are the different classes. Okay, it is just for your knowledge that the crystal systems are also important here. Okay, now for example, fluorite and halite, like let's say halite is your salt, right? Salt cubes. And halite is also a mineral, NaCl. So halite comes under your isometric system. And if we talk about the HM symbol for halite, the HM symbol for halite will be 4 by m, 3 bar, 2 by m, right? So this is the symbol, and this is what we need to decipher in today's video. Okay, so here are the crystal systems. I hope this is pretty basic. You must be knowing about it. Okay, like isometric has what? All the axes which are equal to each other, and 90 degree to each other. Orthorhombic has all the axes which are not equal to each other but 90 degree to each other. इसी तरीके से हमारे पास hexagonal monoclinic and we have here tetragonal triclinic. Okay, all right. So now we come to the main part, that is your symmetry element and operations. Okay, so you know that a crystal is an ordered arrangement of atoms. It means that it should have some sort of symmetry. Okay, so what is symmetry element? Symmetry element is a geometric feature. What is it? It's a geometric feature which expresses the symmetry of an ordered arrangement. Okay, a geometric feature which expresses the symmetry. A geometric feature can be what? An axis, a mirror plane, etc. Right? So this is the symmetry element. Okay, any geometric element which basically expresses the symmetry of a crystal. Okay, and the process that results in this symmetry is known as symmetry operation. Okay, so we will look all the elements and operations. Okay, so there are four main elements which are there in your HM symbols. Okay, what are the elements? First is your mirror plane, second is rotational axis, third is center of symmetry, and fourth is roto inversion axis. So we will look at them one by one. Okay, so like for example mirror plane, नाम से पता चल रहा है mirror. Okay, like if you stand in front of your mirror, you will see a reflection, right? So what is the operation here? Reflection through a plane. Okay, like if I have a dot here and I put a mirror in front of it, I will get a reflection of this dot here, right? So what is the element? Geometric element क्या है यहाँ पे? एक plane है जिसको हम बोलेंगे mirror plane, right? There is a plane here, we will call it as a mirror plane. This is the geometric element. Okay, and the process is known as reflection. Okay, so this is the operation. Then there is rotational axis. Okay, axis is what? A simple line, okay, about which we rotate the about which we rotate the crystal. Okay, so this we will also look by the example. And then there is center of symmetry, inversion through a point. This we will look by an example. Okay, then there is roto inversion axis, rotation with inversion. So we will look at them one by one with an example, and through that example you will get each and every element. Okay, so there are four elements you need to know. So till now I hope it is clear that there are symmetry elements and operations which are important, and four elements are there. Their name you should be knowing: mirror plane, rotational axis, center of symmetry, roto inversion axis. Okay, now we will start with the mirror plane first. So here you can see a mirror plane. Like for example, this loin here or your face itself is almost symmetrical. Okay, so if I put a mirror plane right through this lion's face, you will see that this part this part is a reflection of this part. So you could say that this lion's face has a symmetry element which is known as mirror plane, and it is denoted by small m. Okay, small m. ये आपको ध्यान में रखना, you need to understand this. Okay, and you should be clear about this. It's pretty basic. Okay, so mirror plane is a geometric element and reflection is the operation. Similarly, you can see this butterfly here. If I put a mirror plane here, okay, remember mirror plane is, let's say, this line, so it means that this plane is coming through your screen right now. Okay, it's in 3D. So this plane here, let me make this again. Okay, it's a plane, something like this, just like a mirror. Okay, so this is the reflection of here. So you could say this butterfly has a symmetry element of mirror. Okay, similarly this hand. Okay, so like for example cube has different mirror planes. Okay, if I slash this from here, this is the one mirror plane. Okay, this is the reflection of this. If I slash vertically, you could say that this is this. Okay, so there are diagonal mirror plane also. Okay, so I hope you get the point. like in circle there are infinite mirror plane. If you pass the mirror plane through the center, you will get infinite number of mirror planes. Okay, so I hope you get the point. What is a mirror plane? Okay, it's a symmetry element and the operation is reflection. Pretty basic. Now you have rotational axis. Axis is a line, okay, or you could say in 3D it's a type of line which is coming through your screen. Okay, so if you look at this propeller here, okay, the axis is coming through the center towards your screen. Imagine that this axis is coming through your screen right now, and if I rotate this propeller, you need to understand that by rotating how much degrees, the same shape is coming. Okay, like for example, originally the shape of this propeller is this, and if I rotate this 120 degrees, I will get the same shape. Okay, I will get the same shape. So you could say that this is a threefold rotational axis. Threefold, how does threefold come? You need to divide the 120 degree by sorry, you need to divide the 360 degree by 120 degree, because in a whole rotation you have your maximum number of degrees is 360 degrees. So if you divide by 120, you will get 3, right? So by rotating it 120 degrees, you are getting the same shape. Similarly, if you have a equilateral triangle and you are rotating it 120 degrees, you are getting the same shape. So it also has a threefold rotational axis. Now remember, an object can have multiple number of symmetry elements. So here you can see it also has a, so it has a threefold rotational axis. It means that we are rotating about this axis. Okay, remember that about this axis we are rotating the triangle. So this axis is represented by threefold rotation. Threefold rotation is represented by a triangle. Okay, but you can see that this triangle also have a mirror plane in this section. Okay, so this part is equal to this part, reflection. This plane also, this part is equal to this part, and this plane also. You could say that this triangle has a 3 mirror planes and a 1 threefold rotational axis, right? 1 threefold rotational axis and 3 mirror planes. So similarly, this is a olivine crystal, right? So it has a twofold rotational axis. Twofold means that if I am rotating it 180 degrees, right, by 360 divided by 180 is what? 2. So if I am rotating this crystal 180 degrees, I am getting the same orientation, same shape which was in original condition, right? So through rotating through this axis, इस एक्सिस को पकड़ के आप अगर रोटेट करोगे 180 degrees, you will get the same shape. And you can try this experiment at home if you have a rubber or anything rectangular or cube shape. Okay, rubber probably you will have. तो रबर को एक एक्सिस से आप 180 डिग्री रोटेट करो और अगर सेम शेप आपको मिल रहा है तो इसका मतलब क्या है? That it is having a two-fold rotational axis. Okay. Okay, similarly in this direction also it also have a twofold, it also have a twofold in this direction. Okay, so it can have a multiple number of twofold rotational axis. How much we will also look at that in the next section. Okay, this is just for your information that what is rotational axis. Okay, similarly you can see that rotational axis of cube, अगर हम इस axis पे rotate करते हैं cube को 180 degree, I will get the same shape. लेकिन इस axis पे करेंगे 120 degrees पे करेंगे तो I will get a same shape. It means that it has threefold also. Okay, in different directions. If I rotate the cube 90 degrees, it means that I am after rotating 90 degrees, I am getting the same shape. It means that 360 by 90, you will get 4. So it also have a 4-fold rotational axis. Okay. So you can see a crystal can have different types of rotational axes. Okay. One fold means that it is pretty much asymmetric. I am rotating it 360 degrees, then only I am getting the same shape. Okay, I am rotating the crystal 180 degrees, I am getting the same shape. So the symbol for two-fold rotational axis is like this lens, right? Convex lens. Three-fold rotational axis, a equilateral triangle. Four-fold rotational axis, the symbol is your square. A six-fold rotational axis, it means that I am rotating something 60 degrees and I am getting the same shape. It means that it has a six-fold rotational axis. क्या बोलते हैं? Six-fold rotational axis. So the symbol is your hexagon, right? So this is your under your hexagonal class. Okay. So I hope you get the point. What is rotational axis? Okay. There can be two-fold, three-fold, four-fold, six-fold. मैक्सिमम इज सिक्स-फोल्ड. इसके आगे आप नहीं जाओगे. ठीक है. सो टू-फोल्ड, थ्री-फोल्ड, फोर-फोल्ड, सिक्स-फोल्ड. वन-फोल्ड तो क्या है? एसिमेट्रिक ही है. इसका मतलब क्या है? 360 डिग्री आप रोटेट कर रहे हो एंड देन यू आर गेटिंग द सेम ओरिएंटेशन. ओके. नाउ so here you can see the hexagonal crystal. okay, तो इसको 6-fold rotational axis है. ठीक है. This is the mirror plane passing through this crystal, right? Then there is center of symmetry. okay, और इसको हम क्या बोलते हैं? inversion भी कहते हैं. So till now we have looked at two symmetry elements. okay, third one is your center of symmetry or inversion. okay, both are same. now this is a symmetry element with respect to a point. यहां पे कोई एक्सिस नहीं है, कोई मिरर प्लेन नहीं है, एक सिंपल सा पॉइंट है जिसके अबाउट ये एक एलिमेंट है, सिमेट्री एलिमेंट. ओके, सो वी कॉल द पॉइंट इन्वर्जन सेंटर एंड ऑफन डेजिग्नेट इट विद द लोअर केस आई. तो सिंबल क्या है इसका? स्मॉल आई. ओके, द सिंबल ऑफ द सेंटर ऑफ सिमेट्री इज स्मॉल आई. ओके, now you have to remember that similar to mirror planes we get an image which is same. okay, but it is inverted in every aspect. okay, let's say कि जो ओरिजिनल पोजीशन है, ये कॉफी का मग आपको दिख रहा है और इसके ही लेट्स से कि ये क्यूब है हमारे पास या कोई सा भी क्रिस्टल है एंड इफ आई एम गेटिंग लेट्स से इफ सम फेस इज हियर. ओके, एंड इसी का ठीक इनवर्ट हमें यहां पे मिल रहा है इन अपोजिट साइड. इफ आई एम लुकिंग थ्रू दिस सेंटर, if I am getting a face or anything, okay, similarly to this shape in the opposite side, but everything is inverted. okay, everything is inverted, ulta ho rakha hai, opposite ho rakha hai. Like for example, this handle was in right side, now this is in the left side. This base was down, here it is up. This open side was up, now it is down. So everything is inverted. okay, if everything is inverted and if you are seeing it through the center, it means that it has a center of symmetry. okay, if you are not getting it, we will see with the example of crystal. okay, so everything is inverted. First you have to remember this, inverted. like for example, this is a crystal, here is the center of this crystal, right? This is in 3D. Here you can see that this part here, and if I look through this center, we can see the same part here also in this side, right? Bottom left. But the position of this face is here at the opposite side, right? And this part is here. So everything is here is inverted, right? You can see, right? This part you can see, let's say this is right and this is left. You are standing here. This is right, this is left. And through this center, if you look at this portion of this crystal, you can see that this face, triangular face, is here in the right side. And this part, this edge is in the left side here. So you could say that this face is inverted, right? It means that it has a center of symmetry, right? तो इसमें I, small I से हम denote करते हैं. Again, you can see this part and this part. Through this center, you can see that this is the inverted image of this one, right? ये पिरामिड कैसा है? अगर हम इसको काट दें तो ये हमें क्या दिखेगा? एक पिरामिड की तरह, इट इज लाइक अ पिरामिड, राइट? इस पिरामिड को हमने ठीक उल्टा कर दिया यहाँ पे, तो इसकी शेप कैसी है? ठीक उल्टी है ना यहाँ पे, राइट? इट वाज अप, नाउ इट इज डाउन साइड. एवरीथिंग हियर इज सिमेट्रिकल. सो हम कुछ नहीं कह सकते इसके बारे में कि भाई ये वाला फेस यहाँ पे या ये वाला फेस यहाँ पे. हम ये कह सकते हैं कि ये वाला फेस इधर की तरफ आ गया, ये वाला फेस इधर की तरफ आ गया, राइट? सो हियर एवरीथिंग इज सिमेट्रिकल, एवरीथिंग इज सिमेट्रिकल. सो you could say that it is the face are also inverted, right? But up and down you can see clearly. So center of symmetry, I think you have got the point, right? And we denote it with the I. Center of symmetry or inversion, both are same, okay? So this you have to remember, opposite and inverted. If you are getting the same type of face, same type of situation, but inverting, okay, through a center, it means that it has a center of symmetry. Now moving to the roto inversion axis. Roto inversion, नाम से थोड़ा difficult लग रहा है, but it is not that difficult. It is a combination of rotation प्लस इन्वर्जन. ठीक है, तो रोटेशन तो हमने पढ़ ही लिया है और इन्वर्जन भी हमने पढ़ लिया है. ठीक है, तो कॉम्बिनेशन है बस. फॉर एग्जांपल, इस कॉफी मग को मैं घुमाता हूं 180 डिग्रीज. सपोज हमारे पास एक क्रिस्टल है, उसका फेस है, लेकिन ओरिजिनल पोजीशन में, इन ओरिजिनल पोजीशन थ्रू द सेंटर वी आर नॉट गेटिंग अ रिफ्लेक्शन एंड इन्वर्शन हियर. But if I rotate this crystal or this shape 180 degrees, you will get the shape this, and then after looking through the center, we are getting the inverted image. It means that it has a roto inversion axis. Roto कितना rotate किया? 180 degrees. It means that two-fold roto inversion axis, right? कितना fold? Two-fold. अगर कोई ऑब्जेक्ट मैं 60 डिग्रीज कर रहा हूं तो इसको कह सकते हैं 6-fold roto inversion axis. If there is 90 degrees, if I am rotating 90 degrees and then after looking through the center I am getting the inverted image, then we could say that it is 4-fold roto inversion. अब इसको हम लिखते कैसे हैं? Like in this example I am rotating in 180 degrees. It means that it is 2-fold rotational plus we are getting the inversion through the center. Look, everything is inverted. This left side, this right side. Coffee यहाँ पे उधर की तरफ लिखा है उल्टी वाली साइड पे. Now coffee is written here. This is downside, this is upside. Okay, this is upside, this is downside. So everything is inverted after rotating 180 degrees. It means that it is getting two-fold roto inversion axis. ठीक है, तो इसको लिखेंगे कैसे? इसको लिखेंगे हम 2 बार से. कैसे लिखेंगे? 2 बार. We write it with 2 bar. If I'm getting 3-fold roto inversion, 3 bar. If I'm getting 6-fold roto inversion, 6 bar. You get the point? Okay. So crystal structure is rotated as well as inverted. So this is known as roto inversion, and notation is like 3 bar, 2 bar, 4 bar, 6 bar. Okay. So these are your 4 symmetry elements. Okay. Here again you can see the examples. Okay. Like in 2 bar we are getting what? Rotating 180 degrees and then inverting. तो इसको मैं rotate करूंगा 180 degrees, ऐसा कुछ आएगा, invert करूंगा through the center. Okay, so this is equivalent of a mirror plane also. मिरर प्लेन भी ऐसा ही काम करता है. तो कहीं पे अगर 2 बार आ रहा है तो इसको मैं मिरर प्लेन भी कह सकता हूं. Okay, we can write it as a mirror plane like this, same as a normal mirror plane. Okay, but this applies only for 2 bar. Okay, right? So roto inversion axis is 1 bar, 2 bar, 3 bar, 4 bar, 6 bar. Okay, 1 बार में क्या है, 360 डिग्री रोटेट किया देन इन्वर्ट किया. 2 बार में क्या है, 180 डिग्री रोटेट किया देन इन्वर्ट किया. ओके, एंड द सिंबल्स आर रिटन हाउ? हियर यू कैन सी in one fold it is written IA, in two fold it is written MB. Okay, और इसको हम सीधा 2 बार भी कह सकते हैं. Okay, because 2 bar is equal to mirror plane, so we could write it as 2 bar और MB. 3 fold रोटो इन्वर्जन में हम क्या करेंगे, एक ट्रायंगल बनाएंगे एंड बीच में एक सर्कल बनाएंगे. ट्रायंगल को हम क्या कर देंगे, डार्क कर देंगे. देखो इन नॉर्मल 3 फोल्ड we are representing it by only a triangle, equilateral triangle. In 3 bar, that is roto inversion of 3/4 axis, we are making a triangle and in between we are making a circle. Similarly in 4-fold normal में हम क्या कर रहे थे, एक normal square बना रहे थे, but in 4-fold roto inversion axis we are making a square and then in between we are making a lens, 2-fold lens. ठीक है, ये इसका सिंबल है. And in 6-fold roto inversion we are making a hexagon and in between we are making a triangle. So this you have to remember. Okay, now okay, so you have to remember 2 bar is equal to mirror plane and also 6 bar is equal to 3-fold axis plus a mirror plane perpendicular to that 3-fold axis. Okay, it is similar to this. अगर हम 6 बार कह रहे हैं तो इसका मतलब ये है कि 3-fold rotational axis and a mirror plane perpendicular to. So this you have to remember. Okay, these are just an example. Okay, so now we will talk about HM symbols. तो हमने क्या कहा था, symbolic representation of the symmetry elements is known as HM symbols. तो अब किसी क्रिस्टल में क्या है, जरूरी नहीं है कि क्या होगा, सिर्फ 2-fold रोटेशनल एक्सिस होगा, कॉम्बिनेशन भी हो सकता है. डिफरेंट क्रिस्टल में डिफरेंट कॉम्बिनेशन होते हैं. ठीक है, तो उनको हम क्या कहते हैं, पॉइंट ग्रुप्स या क्रिस्टल क्लासेस. व्हाट वी कॉल इट एज पॉइंट ग्रुप और क्रिस्टल क्लासेस. पॉइंट ग्रुप्स और व्हाट, कॉम्बिनेशन ऑफ द सिमेट्री एलिमेंट्स. ओके, ये जो 4 हमने एलिमेंट्स पढ़े हैं ना अभी, उनका कॉम्बिनेशन क्या होगा, उनका कॉम्बिनेशन क्या होगा, पॉइंट ग्रुप. ओके, द कॉम्बिनेशन ऑफ द सिमेट्रिक एलिमेंट्स आर नोन एज पॉइंट ग्रुप्स और क्रिस्टल क्लासेस. बोथ आर सेम. ओके, crystal classes are exclusively used for crystallography. Okay, now in the mineralogy or in the crystallography you are getting 32 point groups, यानी कि 32 कॉम्बिनेशन ऐसे हैं जो क्रिस्टलोग्राफी में आपको देखने को मिलते हैं, और 32 क्रिस्टल क्लासेस इसको हम कहते हैं. ठीक है, इन एलिमेंट्स का कॉम्बिनेशन, इन एलिमेंट्स का कॉम्बिनेशन. अब हमने ये तो देख लिया. देखो आई क्या होता है, सेंटर ऑफ सिमेट्री और इन्वर्जन. एम कैन बी रिटन एज 2 बार. ओके, यानी कि 2-fold रोटो इन्वर्जन या मिरर प्लेन. 1-fold रोटेशनल एक्सिस, 2-fold 3-fold 4-fold 6-fold. ठीक है, 3 बार 4 बार 6 बार को हम क्या कहते हैं, 3-fold रोटेशनल एक्सिस एंड अ मिरर प्लेन परपेंडिकुलर टू इट. तो कहीं पे आपको जैसे 3/m आ रहा है, इसका मतलब क्या है कि 3-fold रोटेशनल एक्सिस and a mirror plane is perpendicular to that axis. Okay, let's say this is the axis, so mirror plane is perpendicular to this axis, यानी कि 90 डिग्री टू दिस एक्सिस. ओके, तो वहां पे हम सिंबल क्या करते हैं, बाई, ये स्लैश हम डाल देते हैं. तो कहीं पे आपको ऐसा स्लैश दिख रहा है, इसका मतलब क्या है कि मिरर प्लेन जो है वो परपेंडिकुलर टू दैट एक्सिस. ओके, नाउ वी विल मूव ऑन टू दी 32 पॉइंट ग्रुप्स. ओके, तो सीधा हम चलते हैं, ये क्लियर नहीं है तो यहाँ पे, ठीक है. दिस इमेज यू कैन फाइंड इन नेट. ओके, तो ये 32 जो क्रिस्टल क्लासेस हैं, 32 पॉइंट ग्रुप जो है, कॉम्बिनेशन जो है सिमेट्री एलिमेंट्स का, वो किसके अंदर आता है, क्रिस्टल सिस्टम्स के अंदर आता है. देयर आर 7 क्रिस्टल सिस्टम्स, ट्राइक्लिनिक, मोनोक्लिनिक, ऑर्थोरोम्बिक, टेट्रागोनल, हेक्सागोनल, आइसोमेट्रिक. राइट, हेक्सागोनल जो ट्राइगोनल है, सॉरी जो ट्राइगोनल है वो हेक्सागोनल के अंदर आता है. ठीक है, दिस वन इज ट्राइगोनल. ओके, सो हियर यू कैन सी देयर आर 32 टोटल. आप गिनोगे इसको, क्रिस्टल क्लासेस को गिनोगे तो आपको 32 क्रिस्टल क्लास देखने को मिलेंगी. 32 क्रिस्टल क्लासेस यू विल गेट. तो हियर यू कैन सी द नोटेशन हियर, ये जो नोटेशन है ना, दिस इज द HM सिंबल एंड दीज आर द नेम ऑफ द क्लासेस. ये अभी आपको पढ़ने की जरूरत नहीं है. दीज आर द नेम ऑफ दीज क्लासेस. एवरी HM सिंबल का नेम है. ठीक है, एवरी HM सिंबल हैज अ नेम. ओके, एंड these are the symmetry elements. Okay, like for example let's start with the isometric. ठीक है, आइसोमेट्रिक में हमारे पास 5 क्लासेस हैं. वी आर गेटिंग 5 क्लासेस: टेट्राहेड्रल, डिप्लॉइडल, जाइरोइडल, हेक्स टेट्राहेड्रल, हेक्स ऑक्टाहेड्रल. ओके, 4 by m, 3 bar, 2 by m. This is the combination of the symmetry element. We could also say that this is the point group. Point group noted by HM symbol, denoted by HM symbol. लेकिन HM सिंबल की कहानी यहीं से शुरू होती है. ठीक है, इसके अंदर हम कैसे डिसाइफर करेंगे कि क्या 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 है. देखो, हेक्स ऑक्टाहेड्रल क्लास में ना 3 एक्सिस ऑफ 4 फोल्ड होते हैं, 4 एक्सिस ऑफ सॉरी, हेक्स ऑक्टाहेड्रल क्लास में क्या होते हैं, 3 एक्सिस ऑफ 4 फोल्ड, 4 एक्सिस ऑफ 3 फोल्ड रोटो इन्वर्जन. ओके, 6 एक्सिस ऑफ 2 फोल्ड and 9 mirror planes. Maximum number of symmetry elements you will get in the hex octahedral class. अगर सारे 32 classes, if you take 32 crystal classes or 32 point groups, out of those point groups, hex octahedral class of the isometric system will have the maximum number of symmetry elements. Okay, तो अभी तक आपको बस इतना ध्यान में रखना है कि आपको टिल नाउ I think it is clear that what is symmetry elements and how we write those symmetry elements. In the next class we will discuss about that how we write the HM symbols for these classes. Okay, so till then stay safe and goodbye. I hope you like this lecture, and if you like this lecture do comment down below. Okay, मिलते हैं next video में. Thank you.